This is Learning Assessment Problem E2.9. The problem-solving strategy to be applied here is that of single-loop circuits and Kirchhoff's voltage law. The question is, what is the voltage between nodes B and D in this circuit? The circuit's somewhat interesting because there's a dependent source whose amplitude is 10 times the voltage VR1 appearing across one of the series resistors in the circuit. So proceeding with the analysis, we'll try to solve first for the voltage VR1, and we'll do this by writing a KVL equation around the entire loop. So beginning at node D, we have minus 12 volts plus VR1 plus VR2 plus the dependent source, which has an amplitude of 10 VR1, and that's equal to 0. We're back at node D. So we can solve this expression for VR1. 11 VR1 is equal to 12 volts minus VR2. But we're told that VR2 is 1 volt in the circuit, so this is equal to 12 volts minus 1 volt. 11 VR1 is equal to 11 volts, or VR1 is equal to 1 volt. Now we'll try to solve for the desired voltage VBD. So again, we'll use a closed path, which is node D, going around to node A, to B, and back to D. So I'm going to choose that closed path, which includes the voltage VBD. And if we do the summation of voltages there, we have minus 12 volts plus VR1 plus VBD is equal to 0. VBD is equal to 12 volts minus VR1. But we determined previously the value of VR1 is 1 volt, so VBD is equal to 12 volts minus 1 volt, and therefore VBD is equal to 11 volts.